In this question, let us say root of pi is a. So we are having a to the power so we can write this thing as I have simply applied the properties of logarithm. So we can write so the whole thing within the bracket is an infinite GP. So I am applying the formula for the sum of infinite GP, that is a divided by 1 minus r. So that gives us a is basically root of pi. So I'm substituting the value. So it will be pi to the power half whole to the power. So 2 goes off. So we are left with pi to the power log x base pi. Hence the answer is x.
Thus x equals to 3. Therefore, option C is correct.
Okay, let us move for the next one. The second question is A0 is 0 and AN is, this relation is given and it has been said that N is greater than equals to 1. So we have to find out the remainder obtained when A suffix 2010 is divided by 11. Now in place of N, if I put, let us say 1. So what we are getting? A1 is, A0 is 0, so A1 is coming to 1. Now if I put N is 2, so we are having A1 is 1, so it's like 3 plus 1, okay? Now if I put N is 3, what we are getting? We are having, now A2 is 3 plus 1, so I'm replacing that. So if I open the bracket, it's 3 square plus 3 plus 1, right? Now, what will be A4? In place of N, I am putting 4. So we are getting A3 can be written as, so we are having, okay. So have you observed this? A base 4, I mean A suffix 4 is ending with 3q. So obviously, if it is A2010, if we move on doing this, we are going to have something like this. Isn't it so? It is always 1 less than the number given in the suffix. Now it is it's a GP. Total number of terms are 2010. So the sum will be, so we are having 2 times A 2010 is 3 to the power 2010 minus 1, right? Now, the question is when A2010 is divided by 11, what is the remainder? Now, here I am applying Fermat's little theorem. It states that we all know that A to the power P minus 1 and 1 is congruence modulo P, where P is prime. And GCD of A and P is 1. That is, A and P are co-prime. Okay. Then Fermat's little theorem states that a to the power p minus 1 and 1 is congruence modulo p. So in this case, we can observe that 3 and 11, they are co-prime numbers, and 11 is a prime number. So we can say 3 to the power 11 minus 1 is 1 modulo 11. So 3 to the power 10 is basically 1 modulo 11, right? Now what do you mean by that? Now when 3 to the power 10 is divided by 11, when 3 to the power 10 is divided by 11, the remainder is 1. So if I raise the power to 3 to the power whole to the power 201, so again the remainder remains the same. So 3 to the power 2010, when divided by 11, the remainder is 1. Is it clear? The remainder is 1. Okay, so 3 to the power 2010 minus 1 is completely divisible, by 11. Okay, it is completely divisible by 11. Therefore, 2 times A2010 is completely divisible by 11, and as 11 is a prime number, so we will say that A2010 is definitely a multiple of 11. Multiple of 11. Is it clear? Therefore, the remainder is nothing but 0. Hence, option A is correct for this problem. Now, in this question, we have to find out the sum till 50 terms. So, the nth term of the given series is, now if I separate, now I'm writing n square as so here what x's we have written. Here is actually n square factorial n we are getting. So here we have added 3n factorial n. So I have to subtract that. And at the same time we have added 2 factorial n, which is again to be subtracted. So we are getting now this 4n factorial n can be written as n plus 1 minus 1. I have manipulated this n in the way n plus 1 minus 1. So it is n plus 2 factorial n plus 2 factorial minus 4 times so we are getting Tn as right. Now I'm putting n equals to 1, 2, 3, 4 till 50. So what we are getting? So for 2 we are having, for 3 we are having, similarly T4 will give us, and this thing goes on, right? So what is our T49? And T50 will give us Now, if I add the corresponding sides, we are going to have, in the left hand side, we are going to have S50. And in the right hand side, see this one. If I add it, this part will get cancelled. Root factorial 3 minus 4 factorial 3 plus 3 factorial 3. Again, similarly, 4 will go off. And this thing goes on. Similarly, this will be cancelled with the previous term, which is here, with this one. Okay? And then again, this part will be definitely get cancelled with the previous two terms, right? So we will be left with this one. If I simplify, we are going to have minus 8 plus 3 plus 6. And here we can write 52 into 51 factorial minus 3 times 51 factorial plus 1. So we are getting here, if I take 51 factorial common, so 49 into, hence option B is correct for this problem. Okay? This is question number 4. We have been given x1 is half and the relation is xk plus 1 is xk square plus xk. So now we can write this thing as I'm writing the left hand in the right hand side in this way. Okay. So if I take this part in the left hand side and this part in the right hand side, we are having okay. So this relation we got. Now let me put k equals to 1, 2, 3 till 100. What we are getting? And this thing goes on. So the last term, when we put k equals to 100, we are going to have Is it clear to all? Now, if I add the corresponding sides, in the left hand side, we are going to give, we will get the given expression. And in the right hand side, if you observe, we will find that this, again, these terms will get cancelled. So ultimately, we will be left with 1 over x1 minus 1 over x suffix 101. Now, we have been already given that x1 is half. Therefore, 1 by x1 will give us 2 minus 1 over x suffix 101. Now, we have to find out the greatest integer value for this expression. Now, we can easily see from the given relation that we are having xk plus 1 is xk squared plus xk. Now, if I put k equals to 1, we are going to have x2 as x1 squared plus x1. So that gives us x1 is basically half. So this one will give us 1 over 4 plus 1 over 2. So that gives us 3 over 4, right? Now if I put x3, we are going to have, in place of k, I am putting 2. So we are having x3 equals to x2 squared plus x2. Now x2 is 3 over 4. So this gives us So this is basically, if we simplify, we are going to have 9 plus 21 over 16, right? 21 over 16. So we can easily see that 1 over x3, as this is greater than 1, so 1 over x3 will be less than 1, right? Similarly, if we move on, if we go for x4, x5 and so on, these all values will be more than 1. Eventually, when we reach x suffix 101, this will be also greater than 1. So 1 over x 101, this will be less than 1. If it is less than 1, then this expression, this part will become what? This part will become 2 minus some fractional value. Some fractional value. And if it is a fractional value, then this value will be little less than 2. Therefore, if we take the greatest integer function of this function, then we are having the greatest integer value of this function. Now, 2 minus some fraction, it will be 1 point something. Therefore, its value will be 1. And that will be our answer for this problem. Hence, option D is correct. So, for this problem, your option D is correct. Is it clear? Okay. Now, so this problem. In this question, they have said that alpha, beta are the two roots. Alpha, beta are the two roots of this given equation. X square minus 36x plus lambda equals to 0. So therefore, we can write that alpha plus beta is 36 and alpha beta is lambda. Now, we have to assume the minimum value of lambda and we have to find out the value of the given expression. That is root alpha plus 2, root beta plus 2 divided by mod of alpha minus beta. So, lambda assumes the minimum possible value. So, for that, what I am doing, we are having lambda equals to alpha beta and beta is replaced by 36 minus alpha, which is coming from this relation. So, we are basically having 36 alpha minus alpha square. Alpha square minus 2 into 18 alpha plus, let me just add 18 square. So, I have subtracted 18 square, so I have added 18 square over here. 18 square is 324 minus this is alpha minus 18 whole square, right? So, if lambda will take the minimum value, if it takes the minimum value, so obviously alpha minus 18 should take the maximum value. Okay. Now, when it will take the maximum value? It will take the maximum value as we are having alpha plus beta is 36. So, the maximum value that alpha can take is 36. It cannot exceed 36. Now, if I take alpha as 36, then beta comes to 0. And as they have said that alpha and beta all belongs to natural number. Therefore, your beta cannot take the value 0, right? So, to make it maximum, we cannot take alpha as 36. So, the next value we will take, that is alpha is 35. If alpha is 35, your beta gives us 1. Okay? Because alpha plus beta is 36. Now, your lambda becomes what? Lambda becomes 35 into 1. That gives us 35. But there is another condition given that lambda over 5 does not belongs to any integer. But if lambda is 35, then lambda over 5 gives us 7, which is an integer. So this value also we will not take. So we will take the next one, that is alpha is 34. If alpha is 34, then beta comes to 2, because alpha plus beta is 36. Now, in that case, your lambda gives us 34 into 2, that is your 68. And this 68, when divided by 5, does not belongs to an integer, right? So, to assume that lambda is taking the minimum value, we have to take the maximum value of alpha minus 18 whole square, and eventually we are getting that your alpha will take in that case 34 and beta will take 2. Therefore, the required value of the given expression, which is alpha plus 2 into beta plus 2 divided by mod of alpha minus beta, is basically root 36 into root 4 divided by modulus of 34 minus 2. So we are getting 6 into 2 divided by 32. Now if I cancel, so we are getting the answer as 3 over 8. Therefore the value of this expression is 3 over 8. Hence option A is correct. Okay. The next question. Question number 6. If we observe the three relations which is given to us, we can easily see that the equation will have three roots, A, B and C. So if we try to simplify this, we are going to have which is equals to x times x minus 1, x minus 2. Okay? Now, this equation, it has three roots A, B, C. Now, they have asked for to find out the value of A into B into C. That is, they want to find out the product of three roots. And we all know it's a cubic equation, right? It's a cubic equation. So, we know that for a cubic equation like this, the product of three roots will be, if the roots are say alpha, beta and gamma, so we will say alpha, beta, gamma will be minus of d over a. Okay, so in this case, in this particular relation that we got, here we have to find out what is the coefficient of x's cube, which is clearly from this equation, we are going to have x's cube from this expression and the coefficient will be 1. And we have to find out what is the constant term for this cubic equation. And the constant term will obviously come from this part, which is nothing but your only 2. Isn't it so? It's 2 because constant will come from here. No constant will come from here or from here. So when we take everything in the right hand side, you are going to have that constant term as minus of 2. Right? Everything in terms of when we converted everything in, when I have shifted everything in the right hand side, you are getting the constant term as minus 2. Therefore, the product of three roots will be minus of minus 2 divided by 1, as the coefficient of x's cube is 1. Hence, the answer will be 2. Therefore, the value of ABC is nothing but 2. Hence, option B is correct. Okay, the next problem. So in question number 7, we have been given that Px is x to the power 6 minus x to the power 5 and Qx is, and they have said that alpha, beta, gamma delta are the roots of qx equals to 0. So what I'm trying to do, I'm simply dividing px by qx. So how we can write that? Just normal division. And if we subtract, we are having this. Okay. So now plus 1 will give us. And if we again subtract, we are going to have x squared minus x plus 1. Therefore, your px can be written as quotient into qx plus the remainder. This is the easiest way of doing this sum. Now, we have been said to find out the values of p alpha plus p beta plus p gamma plus p del. Therefore, your p alpha will be this part. If you put alpha, beta, gamma or del, every time it will become 0. Why? Because if I put alpha, then this part will give us q of alpha. And since alpha is a root of qx, therefore q of alpha will become 0. So it is same as for beta, gamma as well as del. So p alpha will be only this thing, right? Because the first one will become 0. Similarly, what will be p beta? Similarly, p gamma and p delta. Okay. Now, we have been said to add this 4. So, we are having which is equals to plus 4. Okay. Now, you see alpha, beta, gamma, del are the roots of qx equals to 0. That is, so sum of all the roots will be, we can write this thing as sigma alpha also. This is the way of writing. So it is nothing but your 1. And sigma of alpha beta will be minus 1. Okay. So now if I square the first relation we are having, this is 1. So that gives us actually and we need to find out this. Let me just denote this thing as S. And sigma of alpha beta is minus 1. So we are having S as nothing but 1 plus 2 gives us 3. Therefore, the value of this expression is nothing but 3. The value of this expression, as we all got from number 1, it's 1. And this is 4. So, the answer will be 3 minus 1 plus 4, which gives us 6. Hence, option B is correct for this problem. Is it clear? This is our next problem, number 8. The question is, alpha, beta, gamma are the acute angles and we have cos theta as sin beta by sin alpha, cos phi as sin gamma by sin alpha. And the second relation that is given to us is cos theta plus phi is sin beta sin gamma. Okay, and we have to find out the value of tan square alpha minus tan square beta minus tan square gamma. So we can easily see that the value that we need does not contain any theta and phi. So all we have to do is we have to remove this theta and phi from this relation. From this relation, let us denote this thing as relation number 1. From this relation, if we can remove theta and phi, definitely we are going to have a relationship between alpha, beta and gamma. So this can be written as let me first take sine theta, sine phi in the right hand side. And let me replace cos theta by and cos phi by, right? So let me take sine beta, sine gamma common. So we are having it's sine beta, sine gamma into cos square alpha over sine square alpha. Is it clear? From here we can write sine square alpha as divided by sine theta, sine phi. Again, you see in the denominator we are having sine theta, sine phi. That has to be removed. That is, you have to convert that thing in terms of beta and gamma so that we will get a relationship between alpha, beta and gamma. Otherwise, we will not get it because theta and phi is an unnecessary element in our problem. So, but we cannot replace sine theta and sine phi because we don't have any direct relation of sine theta and sine phi. But we are having the relationship with beta and gamma with your cos theta, cos phi, right? So I have to convert the thing in terms of cos theta and cos phi, and for that I am squaring both sides. In the denominator we will have sine square theta, sine square phi. Sine square theta can be written as 1 minus cos square theta. Similarly, 1 minus sine square phi. Now, cos theta we know that we are having basically 1 minus cos square theta. I will replace this thing by, and sine square phi I will replace this thing by, I'm sorry, this thing will be cos square phi. I'm sorry, this thing will be cos square phi. So cos phi will be replaced by sine gamma by sine alpha. So it will be sine square gamma by sine square alpha. So after simplifying, we are going to have sine to the power 4 alpha in the numerator divided by sine square alpha minus sine square beta into sine square alpha minus sine square gamma, right? Which is your sine to the power 4 alpha. And we can cancel this thing from both sides. So if we cross multiply, we are going to have sine square alpha minus sine square beta. And in the right hand side, we are having, okay. So now let me just multiply this. Sine to the power 4 alpha minus and in the right hand side we are having sine square beta, sine square gamma, and this is cos to the power 4 alpha, which can be written as cos square alpha whole square, and cos square alpha can be written as 1 minus sine square alpha whole square. Now if you open this, sine square beta, sine square gamma This goes off from the both sides, and you can easily see that we are having sine square alpha common. So let me just cancel from both sides. So we are having sine square alpha. If I remove from both sides, that is, I am dividing both sides by sine square alpha, we are getting this thing we got. Now let me take this thing in the left hand side. So we are having in the right hand side, we are having sine square beta plus sine square gamma minus 2 sine square beta sine square gamma. So actually we are having sine square alpha is basically sine square beta plus sine square gamma minus 2 sine square beta sine square gamma divided by 1 minus sine square beta sine square gamma. So if this is your sine square alpha, so what will be your cos square alpha? 1 minus sine square alpha. So that gives us 1 minus this whole thing. And if we simplify, we are going to have so the numerator after simplification, this one and this one, we can simplify. So now if we just factorize this, so we are having 1 minus sine square beta 1 minus sine square gamma divided by 1 minus sine square beta sine square gamma. So that is basically cos square beta into cos square gamma divided by 1 minus sine square beta sine square gamma. Is it clear? This sum is pretty lengthy sum. It's true. This is the only sum given in this paper which is little lengthy. So we got this value is basically your cos square alpha. This is your cos square alpha. And what about your sine square alpha that we got? We got this thing as our sine square alpha, right? This is your sine square alpha. Now if I divide this two, we are going to have tan square alpha, which is your sine square beta plus sine square gamma, sine square beta plus sine square gamma minus 2 sine square beta sine square gamma divided by cos square beta cos square gamma. That's it. Now let me do one thing. I'm taking sine square beta common, so it will be 1 minus this 2 sine square beta sine square gamma. I'm writing it as sine square beta sine square gamma minus sine square beta sine square gamma. And if I take sine square beta common, we are left with 1 minus sine square gamma. And from the second one, if I take sine square gamma common, we are having divided by cos square beta cos square gamma. So this is basically sine square beta cos square gamma plus sine square gamma cos square beta divided by cos square beta cos square gamma. Now if we separate, we are going to have sine square beta cos square gamma divided by cos square beta cos square gamma will give us tan square beta. And for the second one, this one when divided by cos square beta cos square gamma, it will give us tan square gamma. From here we can write tan square alpha minus tan square beta minus tan square gamma is basically 0. Hence option B is correct for this sum. This sum is pretty lengthy sum. So try this sum for several times so that you will be comfortable with this kind of problems which may come in the future days. Okay, let us move for the next problem. So in this question, before starting the sum, we have to first define the function, define the inequality which is given to us. So first of all, to define this log, 1 over x has to be greater than 0 implies your x has to be greater than 0, and at the same time x cannot be equals to 1, and which is inside the log has to be greater than 0. So the critical points that we are getting is minus 1, 2 and 5. So your x will come here and here. Therefore your x is lying between minus 1 and 2 or 5 less than x less than infinity. Okay. So combining this and this, we can say that your x is lying between, as x is greater than 0. So we will write that x belongs to 0 to 2 or from 5 to infinity. But be careful, you cannot take the value 1. Okay. So this is the values of x for which the given inequality or the logarithm is defined. Okay, so now to the actual problem. In the base of logarithm, we are having 1 over x. So we have to consider two cases. Case 1, we are assuming that your x is lying between 0 and 1. Okay, x is lying between 0 and 1. If x lies between 0 and 1, eventually your 1 over x is more than 1. Therefore, the given logarithm will become is greater than equals to 1 by x to the power 1. So that gives us 1 over x. So therefore, we can write so now if I take the LCM, so it is 2 times x minus 2 minus x plus 1, x minus 5 is greater than equals to 0. So from here we can write 2x square minus 4x minus x square plus 4x plus 5. So we are having in the numerator x square plus 5 because 4x goes off. X into x plus 1 into x minus 5 is greater than equals to 0. So this part x square plus 5, we all know that for all real values of x this is always positive. Therefore our critical points comes to be minus 1, 0 and 5. So plus minus plus minus. So your x will come here, x will come here, or x is lying between minus 1 and 0 or it is more than 5. But you have assumed that your x is lying between 0 and 1. As x is lying between 0 and 1, so I'm sure that from this one, we are not getting any values of x. Moreover, one thing to be very careful, that is in the given definition, your x is more than 0, right? So under any circumstances, this part will never come. So the actual solution for this one will be x is more than 5. But we have already assumed for this case that x is lying from 0 to 1. Hence, from this, when x is lying between 0 and 1, we are getting no solution. We are getting no solution. Okay, now let me consider case 2. In this case, we will assume that your x is greater than 1. Okay, now if x is greater than 1, then eventually your 1 over x will be less than 1. So, we are going to have the same thing. Only thing is that this sign will get changed. That is, we are going to have something like this. Less than equals to 1 over x. So, after simplification, we will have exactly the same thing that we got it here. We got here. The same expression we will get. Because there is no change in values. But this is less than equals to 0. So, in that case, what we will do, we will take the, we will draw the number line, exactly the same number line we are going to have. But here we are going to take the negative region. Therefore, we will say that your x is lying from 0 to 5. Okay, x is lying between 0 to 5 because there is no point of taking any value which is less than minus 1 as your x is greater than 0. And in case 2, we have already taken that x is greater than 1. So, there is no question of taking that region. So, x will be greater than 0, less than 5. So, now if we take the intersection of this one and this one, we can easily see that your x, as well as we must remember that x is greater than 1 here. So, the intersection portion that will come is x is greater than 1 and less than 2. That's it. Okay. So, this is the solution for our second case. But unfortunately, as they have asked for the number of integers that we are getting from this inequality, and between 1 and 2, there is no integers. Hence, there will be 0 integers for this case, which is going to satisfy because there is no integer lying between 1 and 2. Hence, there is no integral values of x for which this given inequality is satisfied. Hence, my answer in this case will be 0. That is, no integral values possible. Okay, so let us move for the next sum. This is our last sum for this weekly test. We have to find out the value of 3 times sigma. R is from 1 to 11 tan square r pi over 24. Okay. So, for a time being, let us do one thing. Let me take pi over 24 be alpha. So, we have to find out the value of tan square r alpha. Okay. That is, we have to find out the value of 3 times tan square alpha, tan square 2 alpha, tan square 3 alpha, tan square 4 alpha, and this thing goes on till tan square 11 alpha, right? Now, what we are trying to do, we are making 2 groups because we can easily see that 2 alpha means it is coming like pi over 12 and pi over 12 is 15 degree. So, we know the value of tan 15 degree. Similarly, we know the value of tan 30 degree and so on. Therefore, what we are trying to do, we are making 2 groups. The first group consists of the elements tan square alpha, tan square 3 alpha, tan square 5 alpha, 7 alpha, 9 alpha and 11 alpha, right? And the second group consists of tan square 2 alpha, tan square 4 alpha, tan square 6 alpha, tan square 8 alpha, and tan square 10 alpha, right? Now, what is tan square 2 alpha? Tan square 2 alpha means I'm doing it separately over here. What is tan square 2 alpha? Tan square 2 alpha is basically tan square pi over 12, which is tan square 15 degrees. And we know this value, it is 2 minus root 3. So that's square. So it gives us, okay. Now, what about tan square 4 alpha? 4 alpha gives us tan square pi over 6, that is 1 over root 3 whole square. So tan square 6 alpha, that will give us tan square pi over 4, that gives us 1. Tan square 8 alpha means it's tan square 8 pi over 24. So it's tan square pi over 3. So that gives us root 3 square, which is only 3. Tan square 10 alpha, that gives us tan square 10 pi over 24. So that gives us tan square 5 pi over 12, which is your tan square 75 degree, that gives us cot square 15 degree, which is same as 1 over tan square 15 degree. And we all know that tan 15 degree is 2 minus root 3 whole square, that gives us 1 over 7 minus 4 root 3. So 7 plus 4 root 3, I'm simply rationalizing it. So 49 minus 48. So that gives us only 7 plus 4 root 3. Okay. So now, if I add all those terms, so we are going to have, from here we are having 7 minus 4 root 3. This one, 7 minus 4 root 3. Plus, this is 1/3. Plus 1 plus 3, and we are having plus 7 plus 4 root 3. So we are basically having 14. This goes off. Plus 1/3 plus 4. So we are having 55 over 3, right? So this part we are getting actually 55 over 3. So let it be in our hand. We will use it later on. Now let us just move for this part. We are having tan square alpha, tan square 3 alpha, tan square 5 alpha. Okay, where alpha is basically pi over 24. So now in this case, tan square 11 alpha is basically tan square 11 pi over 24, which can also be written as tan square pi by 2 minus pi over 24. So that gives us cot square pi over 24, which is simply cot square alpha, right? So this is basically cot square alpha. Similarly, if you check, you will find that tan square 9 alpha can be written as cot square 3 alpha, and tan square 7 alpha can be written as tan square 5 alpha. I'm sorry, cot square 5 alpha. I'm sorry. It's cot square 5 alpha, right? cot square 5 alpha. Therefore, the given expression actually becomes tan square alpha plus cot square alpha, tan square 3 alpha plus cot square 3 alpha, and tan square 5 alpha plus cot square 5 alpha. So if I use a formula of a squared plus b squared, we are having a plus b whole square minus 2ab. Same thing for here. Same thing for here. So this thing is coming like, if we break it in sine and cos, we are going to have 1 over sine alpha cos alpha whole square. Similarly, in this case also, 1 over sine 3 alpha cos 3 alpha whole square. Same thing here, 1 over sine 5 alpha cos 5 alpha whole square, right? And minus 6 is there. So if we multiply with the 2, here if we write 2, and if we give a 2 over here, so we are basically getting 4 over sine square 2 alpha, sine square 6 alpha, sine square 10 alpha minus 6. Now, what is 2 alpha? We all know that alpha is pi over 24. So, sine 2 alpha will actually give us sine pi over 12, which is your sine 15 degree. And sine 15 degree is root 3 minus 1 by 2 root 2. So, sine square 2 alpha will be root 3 minus 1 whole square whole by 8, right? Similarly, sine square 6 alpha will give us sine square 6 pi over 24. That is sine square pi over 4. So that gives us 1 over 2. Okay? And for sine square 10 alpha, we are going to have sine square 10 pi over 24. It means sine square 5 pi over 12. So this is basically sine square 75 degree, which is same as your cos square 15 degree. Therefore, this sum will be 4 over sine square 2 alpha, sine square 2 alpha plus 4 over sine square 6 alpha, right? Sine square 6 alpha plus 4 over, we are having sine square 10 alpha, right? Sine square 10 alpha minus 6. So we got sine square 2 alpha as, if we break it, we are actually having 4 minus 2 root 3 over 8, right? So, and we can cancel also. We can write this thing as 2 minus root 3 over 4. Okay? So, if I put it here, we are going to have 4 over sine square 2 alpha. I am replacing by 2 minus root 3 over 4. So, 4 will go up. 2 minus root 3 in the denominator. Plus, sine square 6 alpha is basically half. So, it will become 4 over half. Plus, and in this case, we are getting, if we open this one, sine square 10 alpha, we are going to have 4 plus 2 root 3 divided by 8. And if we cancel by 2, we are going to have 2 plus root 3 over 4. So let me just replace this. So again 4 into 4, and in the denominator we will have 2 plus root 3 minus 6. So this is 16 and 2 plus root 3. If I rationalize, this is actually 8 minus 6 will give us plus 2. This is again, if we rationalize, 2 minus root 3 divided by, if we rationalize this one, we are going to have 1 in the denominator. So ultimately we are going to have 32 plus 16 root 3 plus 2 plus 32 minus 16 root 3. So this and this goes off. So we are left with 32 plus 32 is 64 plus 2 is 66, right? So for the first one, what we got, let me change the color of the pen. So for the first one we got, for, where it is, for the first one, this one, for this one, just now we got the value of it is 64, right? So this is basically, I'm writing it here. So it's basically 3 times, we are getting 64, right? If I'm not wrong, it's 66, I'm sorry. So we are getting this thing as 66. This is 66 plus the second part, that is this part, we got the result as 55 over 3. So this one is 55 over 3, right? Now if I open the bracket, it is 66 into 3 is 198 plus 55. So if we add, so 253 is the correct answer for this problem. Therefore, question number 10, the answer is 253. For question number 10, the answer is 253. That is the correct answer. Is it clear to all? Okay, see you in the next weekly test solution.